Is it 110? Okay. Great. The real number system. The real number system is, it's a one page, it's not even a whole class lesson really. It's not even really that important in grade 10, but it's going to become hugely important to you in the way you do your math next year. So we like to make sure you see it solidly this year, even though it doesn't really come into play again after this lesson. But it will be a big deal next year. And it will be a big deal in physics and various other disciplines. So we like to make sure we get out of the way now. The real number system is every single number we use to do 99% of the math we do. Okay? It covers everything. But just like anything that covers that much stuff, it's got categories that it's broken down into. The reason it has real number system there is because there is an entirely separate number system called the imaginary number system that was invented by mathematicians to explain things like negative square roots, because they don't exist in our number system. And yet, in mathematical theory, there are places where you need negative square roots, so these imaginary numbers exist in order to do very high-level math. Right? For our purposes, and for the purposes of 90% of you, who are most likely not going to go past first or second year calculus, the real numbers will suffice. Okay? Okay. But bear in mind that they do exist, which allows math teachers to make the following joke. The square root of -1 and pi are in a fight. And pi says, wow.
Pi says eat.
No. Pi says, get real. And root of -1 says, be rational. To make a super fun math nerd joke. Kind of like this super fun one. What did one atom say to the other? What did one atom say to the other?
Hi, Adam.
I lost an electron. What was the response? Are you positive? Because of course,
What did you say?
one atom says to the other, I lost an electron. And the other atom says, are you positive? To which of course he responds, yes! All right.
Because when a proton loses an electron, it becomes positive. I'm not a proton. Never mind, same thing. So whatever. It can actually.
Science class.
I'm kidding.
It's a subtopic for cool show. You want to record all this.
I know. I want all this recorded.
My toe, sis.
Wait, there's this salty joke about like an acid and a base reaction.
Yes.
What was that called again? It was like,
Are you a metal interacting with a non-metal? Because you so salty.
oh, that's the word.
Are we done?
Why is that so salty? Because the lard never waits back.
Why was the sand wet? Because the seaweed. Your brother loves that joke. I'm not sure. I told that joke and your brother didn't get it forever. And for the rest of the year, the joke was, the sea, it weed. And he was,
I'll go tell him that joke.
go home, tell him that joke and see what he says. Say, oh my God, Mr. Meyer told the funniest joke last night. I've never laughed so hard. Why was the sand wet? And he'll go, ah!
Sam?
It'll be funny. Math jokes are good, right? I was the mermaid embarrassed in math class. Her algebra was showing. Ah.
What? I was laughing.
Nothing.
Huh?
Huh?
Math jokes are mostly fun because people don't get it.
Most people don't. All right, so here we go. Let us begin. The real number system consists of these various categories. The first and smallest category, which is kind of stupid to say because, excuse me, it really isn't that, it's not that small. The natural numbers. Now, I'm going to highlight all the names because, like I say, they will get used eventually. The natural numbers, I feel like writing in orange today. I hope you're all right with that. The natural numbers are what I like to call the counting numbers. And what do I mean by that? I mean, take yourselves back, cast your minds back to kindergarten when you were sitting in Mrs. Bagcrumble's class and Mrs. Bagcrumble says, class, let's count together. And she said, okay. And you said, okay, Mrs. Bagcrumble. And she picked up an apple and you all went, one. And then she picked up another apple and you went, two. And she picked up a third apple and you went, three. And that's how we counted. Because it doesn't matter. You had a male kindergarten teacher?
I did too.
Shut up your faces, really? I didn't think such a thing existed.
Mr. What was so awesome? What is the best teacher? What?
Wow. Never ever seen one.
Most elementary school teachers are girls until like the older grades.
Never ever seen one. That's crazy. Yeah, it's usually about grade 4 or 5 you get your first male teacher. Well, see, I had this whole funny thing I do with counting numbers fast. I'm not going to bother.
No, I want to see the funny thing you do with counting numbers, please.
Where does the counting end?
Never.
It never ends. But it's weird because people say, well, you can count till infinity. But infinity is a concept. It's not a number. So it can't really be a natural number, is it?
Some infinities are bigger than others.
So it just goes up. Eventually we run out of names. I don't know what comes past nonillion.
Is that like Googleplex?
Well, a quadrillion has 4 sets of zeros.
And then a non-
Google.
A Google has a million zeros, and a Googleplex is a Google zeros.
Huh?
It has 9 sets of zeros.
Yeah.
No, Google has 100.
A Google has a million zeros.
It does.
And then a Googleplex has a Google zeros. That's
So-
right.
The next one are the whole numbers. The whole numbers are the naturals. Plus 0. So it's 0, 1, 2, 3, 4, up.
So 0 is not a natural number.
No, 0 is not a natural number. Because 0 didn't exist when we first started counting. 0 was invented by an Arabic and an Indian mathematician at very similar times. Nobody
Have you
really
watched that
knows.
movie, the Power of Infinity? It's a math movie. It's about an Indian guy. It's pretty good.
Anyways. So, those are the whole numbers. Now, when you guys hear the word whole numbers, you immediately think of fractions. But please do not.
Why?
Because
It's a whole
fraction...
number.
Yeah, but you think of it as being this situation, 2.5. The 2 is the whole number and the half is the fraction. But you will notice I could give you a negative mixed numeral, yes?
Yeah.
That negative 3 is the whole part of the fraction, but it is not a whole number because it is negative. Got me?
Yeah, I got it.
Aye. So now, the question becomes, thankfully just posed by Sarah, it allows me to jump right into the next thing I was about to say. What have you noticed is not been included in either of the first two sets? Negative numbers. So the integers must therefore then be the naturals plus negatives.
And
0.
Yes. Because naturals. Wait a minute. I should have written wholes. Wholes plus negatives. Sorry about that, guys. So this goes all the way down to what? Infinity minus 1, technically, because that number exists, but infinity doesn't. Negative 1, 0, 1, up. Right? Actually, down wouldn't be infinity minus 1. It would be infinity plus, negative infinity plus 1.
Oh, man.
Oh, yeah.
Wouldn't that just be 1?
No.
No.
Up at this
If
end.
infinity is infinity, then how is there a plus 1? Because infinity
Well,
is
what's
like,
infinity plus infinity?
That's why at this end up here, it's infinity minus 1. Because you're going back to the left.
yeah, but you have back. But like, if it's infinity plus 1.
But
then-
infinity plus 1 can't exist.
Exactly.
I never said infinity plus 1. I said negative infinity plus 1.
What's infinity plus infinity? Bigger?
That's the negative number before negative infinity.
All right.
Is infinity an imaginary number?
Now, yes.
Why does it look like that? Who decided that?
Now, I assume it's because there's no start and end to that.
But there's also no start and end to 8. Or to like ooh.
I just work here.
See, look, there's no start and end to this shape either.
What else is missing?
Fraction.
Fractions. Decimals are fractions' ugly cousin. We do not talk of decimals. Stop speaking of decimals. I hate decimals.
Really?
Yes, because as soon as you guys see decimals, all of a sudden you say, I don't need to know fractions anymore, and you stop learning about them,
And you round off.
which is
scale
silly,
for fraction.
because fractions are infinitely more useful.
I like fractions.
So, rational numbers is, this is where it gets a little snaky, because there's some math definitions here. Rational numbers are anything
That can be put into a ratio.
represented, yes, thank you, as the following ratio.
Following. I thought you said following. Like that.
Okay, but there's some rules. X and Y must be integers or rational themselves, and Y cannot equal 0, because you cannot have a denominator of 0, because it is impossible to divide by 0. It is it is actually infinity. It is an unbelievably large number.
What's an unbelievably large number?
Any number divided by 0.
Where it goes-
Because if you cut 1 into 100 billion pieces, 1 divided by, other way around. If you divide 10 by 1 trillionth, you get a gigantic number of pieces, right?
Yes.
You get 10 times a trillion pieces.
Yes.
And a trillionth is very small. As you approach 0, that number gets unimaginably large, but can't ever get there. Much like if you cut the distance in half between you and me, I will never actually get to you, even though I get to you.
That's so sad.
What if you do 0 divided by 0?
Again, I just said you cannot divide by 0. It is-
Cookies, you can buy them.
So-
With 0 friends.
Oh, yeah. If you ask Siri what's 0 divided by 0,
All right. Now, stop. we must discuss fractions' ugly cousin, decimals. Yes, we must. This is the definition. But since all of us fractions make us cry, we all like to use decimals, we are reminded that if you have a decimal, decimals that end or repeat are also rational. So, we take a moment with this. 1/4. Rational or not? Rational, of course. 1's an integer, 4 is an integer, 0 is not on the bottom. Which means if it exists as a fraction, it also exists as a decimal. 0.25. Ends, right? However, 2/3. Does that exist as a fraction? Yes. It's an integer divided by an integer. Therefore, it's a rational number, correct? But if I do that on my calculator says 0.666. Most calculators go out to the end and then put a 7 there. Well, it's not wrong. It's just your calculator is doing what you think it needs to do. It can't go past that, so it rounds it off. That 6 repeats. Therefore, it is a rational number. All right? Where you get into trouble is if your calculator were to say 1, 5, 5, 5, 5, 5, 5, 5, 5, 2, 5, 5, 5, 5, 5, 5, 5, 5. Is that rational? Well, it might be. Your calculator screen ends, it's just a bunch more 5s, right? Okay, so you gotta have a little bit of knowledge in how to read these things. Okay? Is this a rational number? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. How long can I do that? As long as I want, it still stays rational. But what if I do this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that rational? Yes, because it ended. What if I do this? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 9, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. No.
Yes.
Why?
Because it didn't repeat.
The pattern got screwed up. Everybody good? All right. And then there is irrational numbers, which are everything else. There are some famous ones. For you guys, pi, right? Now, somebody always says, but Mr. Myers, pi is a ratio. It has to be rational because it's circumference divided by diameter, right? But it's not. Because the circumference divided by the diameter is never perfect. Right? If we actually drew out a circle and got a nice perfect circumference of 10, the diameter would be a weird number. It wouldn't be an integer. Everybody cool? All right. So pi is known. There's a lot of famous ones. You guys will use the letter E eventually. The letter E with little x over it is another irrational number, similar to pi. It's an E with a little x above it. It's Euler's constant. It's used in physics. It's another one where you can't ever actually get to it. But for you guys, what you guys are going to use for irrational numbers more than anything are radicals that don't work. So here's what I mean. Square root of 4, what's that? 2. So that is rational because it works. Square root of 3. What's square root of 3? 1.73, blah, 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 blah. It doesn't work, so it's irrational. Everybody cool? Now, sometimes where we get into trouble with this is something like this. The square root of 2.25. Most of you will say, oh, that can't be rational. It's a square root of a decimal. It doesn't work. But it's 1.5. It does work. It's a decimal that ends. Everybody cool? Mr. McCarr.
What about sine of 10?
Uh-huh.
So they're irrational too, right?
Okay. Let me give you an example of that. 3, 4, 5. Right?
Yeah.
Okay. So if that's theta, the tan of theta is 0.75, right? It's a rational number. So what happens though when I do this? When I take that point, so that 0.75, shift tan 0.75 gives me what for an angle? Fills up, doesn't repeat. So we round it off. Picking up what I'm putting down? Okay, and by the same token, if I do tan 37, which is what I would round that off to, I indeed do not get 0.75. Everybody good? All right. So we're all cool with irrationals and rationals? Awesome. Turn your page over while we wait for my computer to not suck. Oh, it turns out it can't possibly do that.
That's just too difficult, I think, for you to ask.
For it to work, you're right. All right. So let's do a bit of math. Make sure everybody remembers how to do this stuff. Rational or irrational? Why? Ends. Now make it a fraction. Three over 25. Why? Lauren.
Because it's the last number of it is in the hundredths place, which makes it 12 over 100, which you reduce to 3 over 25.
Which you simplify to 3/25. Absolutely correct, right? Okay. B, rational or irrational? Rational. Why?
Because it repeats.
Because it repeats. Excellent. Now, make it a fraction. Everybody says 1 over 9 right away. Why? Yeah, but why?
Because 1 divided by 9 is...
Talk to your neighbor. Why?
It's in the 10 spot, and 9 is 1 less than 10.
I will.
Anybody got a reason for me yet? Sarah talked a little bit. She was like, blah, 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 blah. And it's like, I don't know. But she was actually almost exactly right. Really?
Okay.
0.1 repeating is what? 0.1111111 for how long?
Forever.
Forever.
Until the world ends.
Which means it is slightly larger or smaller than 0.1.
Slightly larger. It's got all those extra ones.
It is ever so slightly larger, isn't it?
Yes, look at all those ones.
So if I were to write this number, 0.1, without the repeating bar, it is ever so slightly smaller than 0.111111111, right? Okay. What is this guy as a fraction? 1/10. Now, fractions, rational numbers, have to have integers, yes? So I need to have the same integers. I need to have integers that are slightly larger than that. in fractions, the numbers go the other way, don't they? 1/2, right, is larger than 1/4. So what is the next integer from 10? 9. That's the slightly larger. So 1/9 is ever so slightly larger than that. And when you go to your calculator, indeed, 1 divided by 9, ta-da! Right? Okay. So that means you should all be able to tell me, is C rational or irrational?
C. We don't know.
Rational. You can't really tell what rational is because it's repeating.
Your assumption based on your evidence is that it is rational, yes?
And it has dot dot dot. Does that mean repeat also?
No, dot 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 means it carries on.
Oh, well then it could be irrational.
So rational in appearance,
But it's irrational in disguise.
but we don't know. Because what happens if the 87th decimal place is a 1?
But it's irrational.
And then it goes back to 2s. And then the 174th decimal place is a 3.
Oh.
Then you're definitely irrational. But what if the 174th decimal place is another 1?
Oh, then it's rational because it goes like 2, 2, 2, 1.
Oh my goodness, there was Raja and Jasmine.
All right. Now we come to the trickiest of the trickies. And one of the few times I will show you guys a trick that just happens to be a math trick that works. What is this right now? Rational or irrational? We'll start with that.
Irrational.
So it's rational.
It's rational. Why? Because the 4 repeats. This is really 0.5, 4, 4, 4, 4, 4, 4, 4, how long?
Forever. Get it? Forever.
Yes.
Infinity
Okay,
minus
now,
1.
Now, the question becomes, put that into fraction form. Ay, 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 ay.
It's like
Turn out to convert these in fractions.
it's probably like a.
There's a trick.
It's close to.
Do some experimentation.
So it,
You have some knowledge here. You know that repeaters use a 9.
54 to 90.
So, my good friend Sarah says 54/90ths. Right?
That sounds great.
Sounds great. Let's check. 54 divided by 90.
Why is it 90?
Oh, just not. Because, of course, that is 9 goes into that 6 times, 9 goes into that 10 times.
Right.
6/10 ends. 0.6. All right. So give me another. What's another guess? Pardon me? 54 over 99 is our next guess. Let's go to our calculator. What happens?
It lies to 0.5.
No, your calculator doesn't lie to you. Your calculator only tells you the truth. It doesn't have the ability to think.
54. Oh, wait.
5, 4, 5, 4, 5, 4, etc. into infinity.
5, 4, 5, 4, 5, 4. Ooh, we're getting close.
54 divided by 99.9. 54 divided by 999.
Okay. 54 divided by 99.9. How is that rational? Is that an integer?
No. But
No.
still.
All right.
How about 504 divided by 999? That's not even. That's farther away.
You're never going to get it. I just wanted you to play around a bit.
What is it actually?
I'm about to show you.
4 9.
Do I ever do this? Jeez. Okay. You're right. You needed a 9 on the bottom. Right?
So we were right that.
Now, but 1 9 on the bottom would only cover tenths, yes? What do I need to cover?
Every
100. So I better have something over here, yes? And it can't be 100 because 100 would be 0.54, yes? So it has to be ever so slightly larger than 100, yes? Which makes you want to use 99, yes?
You want to, but
But 99 didn't work, did
it
it?
didn't work.
So what you actually do is the 9 is only there for any repeating digits. So I have a 4 that repeats, so I need a 9. I have no other repeating digits. 0. Everybody cool? Now, you can't do 54 over that though, can you?
Well, you could, but you would get the way after you walk.
So what you actually do is you take what you have and you subtract the non-repeater. So what do we have? 54. And what is the non-repeating part? 5 over 90, which is 49 over 90. And then we go to our calculator and we check. 49 divided by 90.
Whoa.
Ta-da! Now, guys, I don't like saying this. I don't actually know why that works. It's one of the very few things that was taught to me as a shortcut, and I have never bothered to learn why it works.
The whole -5 thing?
I've never bothered to learn.
Why -5? Why not like 6 or something?
Oh, because the 5 was what wasn't repeating. So if it was 1, 7, and the 7 repeated, it would be 16 over 90.
Got you, fam. I understand.
Yeah, but like,
I understand.
oh boy.
Okay. It's a short day. I'm giving you very little work. Do your best to categorize these. You won't have any trouble. And do your best with page 112 in your book, which was 211 in an old textbook that I used to use. Okay?
Okay.
What is this?
How would it be if the repeating multiple is like 1, 2, and then the repeater is like 5, 4, 5?
Okay. We'd follow the same thing, and as soon as my computer thaws, I'll show you. So you're asking me about this.
What if the non-repeat decimal is larger?
You are asking me about this. 1, 2, 4, 5, and that's the repeating part. Okay? So how many repeaters do I have there?
4 and 5.
2, right? So I need 2 9s. How many non-repeaters do I have? And this would be 1245 minus 12, which is
It's a good time.
1233. Okay? All right. Go. I don't feel like teaching anymore. I'm just kidding. I want to teach till I die. But with any luck, the last 10 years will be teaching surfing on the beach in Ecuador,
That would be pretty sweet.
if I'm lucky. I'll be that, hey, you ever go get surf lessons from that old gringo in Ecuador? Oh, yeah, that guy's crazy. He's like 150 and his skin looks like a raisin. That'll be me, if I'm lucky. You guys be like, I hear this legend of a crazy old gringo in Ecuador that just lives on the beach under a house of shells. Oh my God, that guy taught me math.
House of Shells, a TV show?
No, that's House of Cards.
Oh yeah.
And it's not a TV show anymore until the producers decide if Kevin Spacey is indeed some kind of pedophile.
Oh, I started watching like the first episode. I'm like too boring.
No, not boring at all.
Mr. Myers, did you hear about what happened at Yale today?
I did.
Yeah.
That's pretty sad.
It is. Huh?
True?
I would assume so.
Yeah, it is.
I have not gone over there.
The news. Yeah, it is. The article is in the.
There is
It's in the Abbotsford News. Search it up.
every day countless hundreds of people end their life. We find this sadder because it is happening here and we may indeed know the person. But it is no more or less sad than the other hundreds of lives that are going to end by their own hand today. And it is no more or less sad than the countless thousands of lives that are going to end in accidents and tragedy today.
I guess it's
The problem is it hits close to home.
Isn't it technically illegal to take your life?
Huh?
Isn't it illegal to take your life?
Yes.
But if you like
I'm
help
not
somebody,
saying